So, two important formulas that you've seen before and you're going to need to apply here now, and midpoint formula, distance formula. Arguably the midpoint formula is one of the easiest formulas you learn in math. You simply average the x-coordinates and average the y-coordinates, and that gives you the midpoint. So in other words, if I'm in some coordinate system here and I have 2 points, call this point here x1 comma y1, and call this point here x2 y2, the midpoint. That is the point that divides the segment connecting the 2 points into two congruent parts. The midpoint is going to be the average of the x-coordinates and the average of the y-coordinates. Pretty straightforward. The distance formula derives from the Pythagorean theorem, one way that you've seen it derived. So in other words, if I have 2 points located in the coordinate plane, if I want to find the distance between them, if I come across and create the horizontal and vertical segments to create a right triangle, then I'm looking at two distances, call them A and B, and my distance I want to find is D. So D is going to be the square root of A squared plus B squared. And you can find the horizontal distance between the 2 points by subtracting one x-coordinate from the other, and since you're squaring it, it doesn't matter which way you do your subtraction, and then I find the y-coordinate by the same manner, subtracting y-coordinates. And it doesn't matter which order you subtract, because you're going to square that difference. So the second topic in this first section concerns intersection of lines, or non-intersection of lines. If we have two lines that intersect, we know that the point of intersection, the x and y coordinates are the same. So if I looked at those coordinates there at the intersection point, x1 comma y1, let's say, if I had a rule for each line and I were to plug x1 into each line, I'd have the same y1 be spit out, because that point, x1, y1, is on both lines. If I have parallel lines, clearly they share no points in common, and if I were to somehow set y equal to each other, there is no point on both lines where for a given y value you get the same x value. And finally, lines, they say lines can be concurrent, meaning one line, figuratively speaking, lies on top of another, but really what you'll see for the lines is one equation will simply be a multiple of another. And again, that should be review from Algebra 1, what lines can do. The other thing that lines can do, we know lines can be parallel, lines can be perpendicular. Those are interesting things. Parallel lines have equal slopes, and perpendicular lines, we know their slopes are negative reciprocals of each other. That is, if L1 is perpendicular to L2, and I have a slope, for example, the slope of L1 is A over B, then the slope of L2 will be negative B over A, the negative reciprocal. And we'll look at a proof of that in section 1.2, which you may not have seen before. Number 32 on page 6 I've assigned as a bonus problem for the week out of this section. And it's a pretty cool formula. You might have seen it in geometry. It's called either Heron or Hero's formula for the area of a triangle. And all you need to know to find the area of a triangle is the length of the three sides. And so again, this has been assigned as a bonus problem, number 32, on page 6.